So the next section we're going to talk about first part is going to talk about the product and the quotient rule, because so far we haven't had any rules where if you had things being multiplied together that you could just find the derivatives separately and then multiply them. So it says, let f of x be 2x to the fourth and g of x be 3x squared. Is the derivative of the product equal to the product of the derivatives? So let's see. So we're going to do two sides here. So this side is going to be the derivative of the product. And then this side is going to be the product of the derivatives. All right, so if we multiply them first, d over dx just means derivative. So if we multiply f of x and g of x, we get 6x to the sixth. And when we take the derivative of that, 6 comes down, you get 36x to the fifth. On the other side, if we take the derivative of f of x, you get 8x to the third. G of x, you get 6x, and when you multiply, you get 48x to the fourth. So just right there, that's proving the fact that you cannot just take the derivative separately. So there's something called a product rule. So it says that the product of two differentiable functions, f and g, is itself differentiable. Moreover, the derivative, basically how we do it, there's two functions in this case. We take the derivative of the first times the regular second, nothing happens, plus the first function times the derivative of the second function. So if you're multiplying two things, you have two terms left over. And in each case, you should only be taking the derivative of one item at a time, not more than one item. So with h of x, think of this like your f of x and this like your g of x. So if we follow the plan right above in terms of the format, the derivative, we should take the derivative of the first, so that's 3 minus 4x, times the second, nothing happens there, plus the first, nothing happens there, times the second, which we need the derivative of, and we get 4. So again, this is f prime of x, this is g of x, this is regular f of x, and this is g prime of x. So again, you take one derivative at a time, and then regardless, you're still going to have to FOIL this out. So we have 15 plus 12x minus 20x minus 16x squared plus 12x minus 8x squared. So when we combine like terms, we have negative 24x squared. 24 minus 20 gets us a positive 4x plus 15. And that is what your final derivative would be equal to for that one. Okay, so again, one derivative at a time. So with b, we have h, and we have x, and we have sine of x. So that's your f of x, and that's your g of x. So the derivative equals, the derivative of x is 1 times the second, plus the first times the derivative of sine, which is cosine. So again, this is f prime of x, this is g of x, this is f of x, and this is g prime of x. And then we just simplify. So the derivative equals sine of x plus x cosine of x. And there's your answer for that one. All right, last one. We've got two terms, but inside one of the terms is a product rule. So we have 2x and cosine of x. So we have y equals derivative. So this is like your f of x, and this is like your g of x. So derivative of the first times the second, plus the first times the derivative of cosine, which is sine, negative sine, minus 2 cosine x. You don't have to do product rule with the second term because it's only a single term. So this is f prime of x, this is g of x, this is f of x, and this is g prime of x. Again, I'm going to make a little note. No product rule since only one variable. So you can only do product rule if you have two variables that are being multiplied together. So if we just make this look a little nicer, we have 2 cosine x minus 2x sine x minus 2 cosine x, and what you're going to find is the cosines cancel. So you actually only end up with negative 2x sine of x for your final answer for that one. Okay. All right. So technically, could you multiply more than one term? Absolutely. So I'm just going to show you an instance in regards to 3 variables, or not 3 variables, 3 functions. Do you get them often? No. But if you multiplied 2 terms together, you ended up with 2 terms. If you're multiplying 3 terms, you're going to end up with 3 terms. But again, in each instance, you are only taking the derivative of one of them at a time. So first term would be the derivative of f of x, but g of x and h of x stay the same. Second term, f of x stays the same, and now we're taking the derivative of g of x, but also h of x stays the same. Third term, f of x and g of x stay the same, and you take the derivative of h of x. So if we just try one of these, we have x squared sine of x cosine of x. So f of x, g of x, h of x. So one derivative at a time. First one, I'm taking derivative of x squared, which is 2x. Sine x, cosine x stay the same. Plus, now x squared stays the same. Derivative of sine is cosine. And the second cosine stays the same. Third, the x squared and the sine x stay the same. And the derivative of cosine is negative sine. And then the last thing you have to do is just get rid of any double negatives, any double signs. Just make it look a little bit nicer. So you have x squared and then cosine x squared minus x squared, and you have sine x squared for that one. Okay, so again, one derivative at a time, not multiple. So if it helps you to write it above, this is f prime of x, g of x stayed the same, h of x stayed the same. Second one, f of x stayed the same, g of x was the only one that we took the derivative of. Sorry, hold on. H of x stayed the same, and then the third term, f of x, g of x stayed the same, and you took the derivative of h of x.